At the end of the last video, I left you with this homework problem and the suggestion that even though there's an x over 2 in there, I don't need to use a half angle formula, okay? As long as I just have one trig function and one angle, my approach is always the same. Trig function equals number, find the angle. So I'm going to first find the values of that angle, x over 2, in one period of sine, so that would be from 0 to 2 pi. Then I'll find all values of that angle. Once I know x over 2, it's easy to solve for x, because I would just multiply through by 2. Once I've got my candidates for x, I'm just going to list the ones that happen to be between 0 and 2 pi. Okay, these two are going to be my answer to the question. These two are just the work that I do to get there. If I'm solving something, I'm always solving for what the variable is. All right, I want to isolate that trig function. So root 2 sine x over 2 is equal to 1. Sine of x over 2 is 1 over root 2. And I've rationalized that so often, I know that's just root 2 over 2. Now, if I recognize it without rationalizing it, that's okay, because this is part of my work. This isn't my final answer. I expect you to rationalize final answers, but it may be simpler for you to see if you write it in its standard form. It's entirely up to you. So now I'm going to try to figure out what is x over 2, looking just between 0 and 2 pi. So if its sign is this positive number, I know that sine would be positive in quadrant 1, so I'll have a value of x over 2 here. And the other quadrant where sine is positive is quadrant 2. So I'll have an answer for x over 2 here. The reference angle here is just going to be the same as this acute angle right here. Okay. So here, this is an acute angle whose sine is root 2 over 2. I probably recognize that, but if I want to double check, here's my 45, 45, 90. Whoops, that's a root 2. Yep, I am getting 1 over root 2, which rationalizes to root 2 over 2. So here I'm getting x over 2 is pi over 4. Here, alpha is pi over 4, so x over 2 would equal pi minus pi over 4. That's 4 pi over 4 minus pi over 4. So that's 3 pi over 4. Okay. So I've got these two solutions here, pi over 4 and 3 pi over 4. Okay. Now those are answers for what x over 2 could be. I haven't yet solved for x. If I now want to get all values of x over 2, I just add a multiple of the period of sine, which is 2 pi. So this would be pi over 4 plus 2 pi n, or 3 pi over 4 plus 2 pi n, where n is an integer. Excellent. Now I'm ready to actually solve for x. I like to, at least for the first one, just write out the equation. What this is saying is that x over 2 could be pi over 4 plus 2 pi n. Now if you asked me to solve that for x, I would say what I need to do is multiply both sides by 2. So I'm going to multiply through by 2. Here it cancels, so I get x. Here, of course, I've got to distribute that. So in this first term, it's going to cancel with the 4 to give me pi over 2 plus 4 pi n. Okay. So that plus 2 pi n changes when we multiply it by 2. Just like last time, we divided through by 2, and instead of adding a multiple of 2 pi, we ended up adding a multiple of pi. Okay. So what's happening is we're adjusting for the period of this trig function. The period of sine of x is 2 pi. The period of sine of x over 2 is 4 pi. All right, excellent. So we could have that, and then I would have to do the same thing here. So let me just write out up here, all x, it could be pi over 2 plus 4 pi n. Doing the same thing here, I would be doubling both parts. So that would become 3 pi over 2 plus 4 pi n, where n is an integer. Okay, so now I want to get all values of x in the interval from 0 to 2 pi. Okay. So I'm going to just create my little table here for what n could be, and then we had pi over 2 plus 4 pi n. If n is 0, I'm just going to get pi over 2. N can't be negative, or I'd have something too small. Okay. Now, if n were 1, that's too big. I'm not going to have a solution there, so I'm just going to get pi over 2 from this set of possibilities. Now, if I do the same thing here, n, and then 3 pi over 2 plus 4 pi n. If I let n be 0, I'm going to get 3 pi over 2. Now that is in the correct interval. Okay. If n is 1, that's too big. Because I've added 4 pi n, I've gotten too big. So we'll just have 3 pi over 2. Now in this case, it's kind of interesting because I did actually get 2 solutions still. And you might have thought, well, shouldn't we get half as many solutions? We had 2 solutions here. If it's x over 2, shouldn't we have just 1? Turns out we actually get 2. Let's just take a quick look at the graph. If I look at y equals sine of x, that looks like this. It does its thing once over the interval from 0 to 2 pi. And if I'm looking for where that's going to equal root 2 over 2, that happens twice. But notice that happens in the first half of the period. Okay. If I then take a look at y equals sine of x over 2, here's 2 pi, here would be 4 pi. It's still going to hit root 2 over 2 twice in the interval from 0 to 2 pi. That's just half of a period. But if I'd been solving for it equaling a negative value, I'd actually end up with no solutions, because it hits all of its negative values in the second half of its period. And when I stretch the period to 4 pi, I'm going to hit those negative values after I've hit 2 pi. Okay. So for this particular equation, we still have 2 solutions. If I'd been solving for sine equaling a negative value, I would have no solutions. So overall, it balances out so that I'm getting half as many solutions. That just doesn't apply in this particular case. Cosines, you could expect that to happen simply because cosine over its first half period takes on both its positive and its negative values. Kind of interesting to see what's going on with all of that. All right.